All right, we have this question right in front of us. This is what we call a simultaneous equation in mathematics. Now, generally, there are several methods to resolve a simultaneous equation. We have the method we call the substitution method. We also have what we call the elimination method. And we can also use the graphical methodology to resolve a simultaneous equation. But in this particular one, we want to use matrices. And we want to use the concept of matrix to resolve a simultaneous equation. All right, you will be needing a couple of concepts in matrices to be able to resolve a simultaneous equation. Now, the very first step in order to resolve this is for you to bring out, you need to transform this particular equation to a matrix form. So how do you do that? Very simple and easy. You see these values, this is the coefficient, this is equation 1, this is equation 2. And for equation 1, we have two variables, x and y. So you go on to bring out the coefficient of both x and y, and you do the same for equation 2. You use that to form a matrix. This is how you do that. So in this case now, we have 3 here, we fix 3 here, we have plus 5 here, we fix 5 here, we have plus 4 here, we fix 4 here, we have minus 3 here, we fix minus 3. Then we go on to bring out the variables in this form. Now, what this does is just changing the form of the equation to more like a matrix. Now, if you go on to make the multiplication between these two matrices, obviously this is a 2 by 2 matrix, 2 rows and 2 columns, while this is a 2 by 1 matrix, 2 rows and 1 column. If you multiply this particular matrix with this particular matrix, you will arrive at these two equations. Now, the last thing you have to do here is to also change this constant to matrix form by writing it in this format. So if you go on to investigate this, if you multiply these two matrices together, you get a matrix. Equating it to this will bring you back to this equation. So this is us changing the form of our equation to look more like the matrix. So what do we do next? So we can label our matrices. We can call this matrix matrix A. If you will, you can label it as whatever you want to. We can label this as matrix small letter x, or maybe I should use a more, let me use capital letter X, and then I will use capital letter B here. So I'm going to call this first matrix capital letter A, matrix X, and matrix B. So what we have to do next is to try and resolve our equation. Now, for us to solve this equation, we're looking for our variables. That means we're looking for the value of x and y. X and y. And x and y, we can see it's embedded in matrix X. This means that the matrix X is our matrix of interest. We want to find the value for matrix X. All right, let's see the next step right here. What do we do next? What we have to do next, is to go on to, we have A times X equals to B. So what we have to do next is to bring out our matrix X, which will be equals to A inverse times B. A inverse times B. Let me explain to you how we arrive at that. Now, if you remember the concept of inverse of a matrix, you would remember that A inverse times A is equals to identity matrix. So if we have AX equals to B, if we decide to multiply both sides by A inverse times A will give me identity matrix. Then times X, then we'll be having A inverse times B. And identity matrix times any matrix will give you the matrix back. So we are left with X being equals to A inverse times B. So that's how we are able to arrive at this particular equation. So this equation here is where the solution of our matrix will come out from. So all we need to do now is to find x. And to find x, we would go on to find the inverse of A and multiply the inverse of A with B. So finding the inverse of A and multiplying it with B will give me my matrix X. So how do we find A inverse? Of course, A inverse is going to be the adjoint of A over the determinant of A. Now, how do we find the adjoint of matrix A? This is matrix A right here. To find the adjoint of matrix A, what you have to do is to interchange the leading diagonal. So you have -3 and 3, then change the signs of the other diagonal. -5, -4. This gives me the adjoint of matrix A. Now we're dividing this by the determinant of matrix A. How do we find the determinant of matrix A? That will be 3 times -3. Determinant of A will be 3 times -3, which is -9, minus 4 times 5. That will be 20. So our determinant will be -29. So we'll be dividing the adjoint of A with 29. And this will give me -3 over 29, -5 over 29, -4 over 29, and 3 over 29. So this has given me the value for my A inverse. So what I have to do next is to multiply A inverse with B. That is the concept of matrix multiplication. So keep in mind that this is our matrix B. So we go on to bring out the A inverse. Then we are multiplying this with matrix B. So how do you go on with this multiplication? So this is a 2 by 2 matrix. This is a 2 by 1 matrix. This is possible because we have these two values as the same, and we'll be getting a 2 by 1 matrix as our final answer. So let's go on to find the value for our matrix. So we have a 2 by 1 matrix. So we have something like this. How do we find the values here? This is row 1, column 1. As I explained in the video under matrix multiplication, what you have to do is to pick row 1 here and let it come on with column 1 here. That's how you get row 1, column 1. So we have -3 over 29 times 7 plus -5 over 29 times 19. And then we go on to do the other one. That will be -4 over 29 times 7 plus 3 over 29 times 19. So you go on to resolve that, and you'll be getting -21 over 29 plus 19 times 5 minus 95 over 29. That is for the first row. Then the second row we have -28 over 29 plus 19 times 3. That is 57 over 29. Let's find a way to close this up. Okay, so we go on to solving this. That will be 116 minus 116 over 29 as the first one. And we have 57 minus 28. That will be 29 over 29. So this is, if you go on to solve this, minus 116 over 29 will give you 4. That will be minus 4 as my row 1 column 1 and 1 as my row 2 column 1. So looking at this is our X matrix. Don't forget we were trying to solve for our X matrix, which was A inverse times B. So, and this is what our A inverse times B has resulted in. So we can conclude that we have minus 4 and 1. And don't forget our X had the constituent of X and Y. Our X was this matrix. This was our X. So we can conclude that our X value is minus 4 and our Y value is 1. So this is how you solve for a simultaneous equation using matrix method. All right, so let's try and resolve this other question. You can pause this video right now and try and solve this yourself and then follow through on the result gotten. So very quickly, what you have to do is to change this to matrix form, and how you do that is to bring out the coefficient of both X and Y in this way. So we have a new matrix. So this is our matrix form. We've been able to change the equation to have a matrix field. So what you have to do is to label your matrix. I'll call this matrix A, I'll call this matrix X, I'll call this matrix B. And don't forget that I told you already that our matrix of interest is matrix X, because that's where the solution of this equation is going to come out from. So our X is equals to A inverse times B. So we have to go on to find the inverse of A and then multiply with B. So what do we do? How do we find the inverse of matrix A? The inverse of matrix A obviously is adjoint over determinant. You find the inverse of a matrix by finding the adjoint of that matrix, dividing it by the determinant. So how do we find the adjoint of this matrix? This is a 2 by 2 matrix. So what we have to do to find the adjoint is to interchange the leading diagonal and change the signs of the other diagonal. So this is the adjoint of matrix A. Let's go on to find the determinant. So how do we find the determinant? Let's try and attempt to find the determinant right here. This will be 4 times minus 5. That will be minus 20 minus 3 times 2. That will be 6. So we're getting minus 26 as a value of our determinant. So the inverse of A will be equals to adjoint over minus 26. So we can go on to say we have our A inverse as minus 5 over minus 26, minus 2 over minus 26, minus 3 over minus 26, and 4 over minus 26. So this is the value for our inverse. So you can go on to break it down if you will, but for the sake of, I would love to preserve the denominators for obvious reasons, because I would love to, when I'm trying to multiply this with this, I would love to have the same denominator. But you can go on to break it down, you will still be correct. It's not going to give you any issue. So I will only bring out the get the resultant of the sign. Minus divided by minus will be plus, minus over minus will be plus. I'll go on to do just that. and leave. I will decide not to break it down in this particular solution. So, but you can break it down. If you break it down, you will still get the same thing. So let's try and multiply A inverse times B so we can get our matrix X. So we have our value. So we want to find our matrix X. Of course, our matrix X is what houses X and Y, and which is A inverse 5 over 26, 3 over 26, 2 over 26, and 4 over 26. So we're going to be multiplying this with our B value. So X is A inverse times B. So that's what we want to try and resolve right here. So let's try and solve this. Of course, this is a 2 by 2 matrix. And this is a 2 by 1 matrix. Of course, this can be multiplied together because we have the column here equals to the row here. And our resultant will be a 2 by 1 matrix. So we have something like this as our resultant matrix. So this is like a 2 by 1 matrix. I want to fill in the value for row 1, column 1, and row 2, column 2, which is what our matrix, the result, will look like. So how do we find this row 1, column 1? You go on to pick row 1 here with column 1 here. So that will be this times this, 5 over 26 times 10, plus 2 over 26 times 1. That will be 5 over 26 times 10, plus 2 over 26 times 1. And then for the other one, you will have 3 over 26 times 10 plus 4 over 26 times 1. So we have this being 50 over 26 plus 2 over 26. Then we have 30 over 26 plus 4 over 26. So you can see the reason why I wanted to all right, there's a mistake somewhere here because we're supposed to have our minus sign here. I should have written that here. Once we were bringing out the inverse, remember this was all having minus. Then when we divided by minus 26, the minus cancelled out on these three values, but this was going to still be minus. So this is supposed to have a minus sign. So we're going to have our minus sign right here. Minus. So here we're supposed to have minus 4 over 26. So going on to resolve this, we have 52 over 26. This was the reason why I was trying to preserve the denominator so that it will be quite easy. So we have 52 over 26, which is 2, 26 over 26, which is 1. So we've been able to get the value for our hex matrix. And if our hex matrix contains the value x and y, and we've gotten 2 and 1, this means that x here is equals to 2 and our y value is equals to 1. So this is how you solve simultaneous equation using matrix method. All right, I would love you to resolve these equations. We have two different simultaneous equations right here, and I would love you to drop your results in the comment section. And the first question, you can see this is supposed to give you a 3 by 3 matrix. Well, the same procedure that you used for a 2 by 2 matrix is the same you'll be applying here. The difference will just be that when trying to solve the adjoint of the matrix, you will be using the method for a 3 by 3, not that of a 2 by 2. And the same thing goes for the determinant. You have to find the determinant of the 3 by 3 matrix following the procedure for a 3 by 3 matrix. The second question, I hope you don't get confused with 2a minus b, and this is 2b minus 3a. All you have to do is to just to interchange this and rearrange it. That's the simple hint to use to solve that. And then you go on to bring out your matrix in a normal way and go on to get the solution. All right. Thank you very much for joining us. I hope to see you in the next video. Bye bye.